Hello, welcome. Today's video will be based on the use of SolidCAM, an integrated software within SolidWorks. In order to finish assignment 1 part 3, we were required to utilize this software to develop and generate the toolpath for a machining tool. The model that I'm going to be using is the second one, and the reason of my choice is because of the physical properties this model obtains, such as sharp edges and pocketing with curvatures or fillets, and sections where the machine needs to be where it needs to cut, considering also the dimensions for this section. For a better view and a better perspective, I've created beforehand a SolidWorks part, demonstrating the features. Now we're gonna see that SolidWorks provides different options. We're gonna go into SolidCAM part, and we're gonna go into new, meaning. While that is uploading, I just want to mention that the following steps are going to be quite similar to the ones in the assignment, where we need to demonstrate and choose the right tool for the right job. This involving deciding the size of the tool, the material that the machine was going to be interacting with, and all relatable to the RPM and fit rate. Yes. All this because when you were doing the rough cutting to finishing cutting, you will be having the RPM increase and the fit rate decrease to obtain that desired surface finished. Now, moving into the process now, we are gonna go set as metric. We're gonna keep it like that, and we're gonna go external so we can save the part. We're gonna be only focusing on that generation of the toolpath in this process. Now, once you select that, you're going to have options where you're going to be, for example, CNC machine. You'll have to relate the machine that you have to the ones that SolidWorks provide, and the most common one is FANUC. This is also found by going into the SolidCAM folder and seeing these properties. Now, defining our stock. When we click on the stock, we're going to be seeing a green lines appearing. These green lines bordering the model, what you want to do is decrease these parameters to 0, and as you can probably see, they're moving, and these are going to be used as reference, right? So you can see where the machine will be working, and this will be shown more clearly with the next step, which is defining the coordinate system. This section will require you to choose the highest surface of your model. Why? Because it will create a reference coordinate system where it will allow you to know the machine section of work, where the machine is going to work. If we keep on going, we press OK, knowing that all is being set up properly. Now we're gonna fall into the next phase, as mentioned earlier, where you're gonna be deciding and choosing your tool. This section, I will be having a different interaction as in the other videos. I will be choosing that tool from the beginning and then interacting it into the setup for the moment. Now, we're going to choose the first tool. You're going to right click, tool table. We're going to choose the first tool by observing the different physical characteristics in here. We're going to be working on the outside surface first, where we have the sharp edges and the circular face. For this, we're going to be using NMU 10 millimeters, and we're gonna be having, this is recommended by many operators doing CNC, where to not have excessive chip load or any other characteristic that could be implemented into the process, but we're mainly focusing on that toolpath again. So we're gonna save that. The second tool that we're gonna be using will be on reference to the pocketing with the curvatures involved or fillets. For this, we're going to be using a bull nose mill, and the diameter will be determined by the type of fillet. So we'll be having a 4 mu curvature, so we're going to be using a diameter mu. Now for the last bit, which is that section that needs to be cut by the machine, we're going to be using the n mu, but 6 mu of diameter. Why? Because by trial and error, I've observed that this has produced a better accuracy in terms of not cutting excessive material that it's supposed to. So we're gonna have that 6 there, and now we are set with our tools. We are ready to design our operations. So we're gonna go into add milling operation. 3D milling, as mentioned earlier, we're gonna be working on the outside surface first. We're gonna be having the working area. When we define that, we're gonna see that a section being created by the software, where determining where we are gonna be working at. When we choose our tool, we're gonna choose the tool that we've press OK. When we choose our tool, we're going to be choosing that 10 mu, which was the first one, 10, okay, and level, just beforehand, we're going to be interacting with the first 4, sections. Level, on level, this will be related to how deep the machine will go. It says -30. With which it's the whole depth of the model. That's why we're gonna go and click the selected face, changing it to -6 and relating it to how far we want the machine to go. Now technology, we're gonna be going into hatch, providing if you see this image, it kind of shows the type of toolpath that will be produced. Since we are outside, we're going to be using hatch to have a better accurate finish. So we calculate that, and you can see the toolpath that we have created. Now this double line will be sort of like a face or a step of the machine done to be able to cut the desired length. I will show you where it was, but before that I'm gonna simulate this system so you can see what has happened. This was the material before the operation, and after operation this has happened. If we simulate that in a 3D, we have created a toolpath for that desired part. Now moving on quickly, we're gonna go into the second operation, second process. Now for this, we're gonna be interacting with the holes in the middle, the pocketing with the curvatures. For this, we're gonna be selecting this work on selected faces for a better surface finish, and so we don't remove, as well as mentioned earlier, any excessive material that is not supposed to. Now pressing OK. The tool that we've decided to use was the boom mill, and this one was specifically for those curves and for us to have a better surface finish. Now the levels, the same. It's related to how deep the machine will go, and as you can see, it's -12 now, which was not the same. So this will determine. These 4 are the same, so this will determine how far the machine will go. Now technology, we're gonna go hatch. So we're gonna save and yes. Okay. Now as you can see, that's the toolpath that we're gonna be having. That's before the before the operation, and that's after the operation, having as close as we can to have that accuracy right on spot. Now we're gonna be working for that little section. Now for that little section, the reason that I've implemented 3 parts was because this little section needs to be it could be, there could be another method, but I try to be safe, and so I don't cut any excessive material, but it's up to you. So the geometry, we're going to no, the working area, define. So we're gonna click the 2 faces, okay. Oh, I selected that by mistake. Okay, now tool, we're gonna select the tool that we've selecting the tool that we already defined for this process, 6 μ. The level again in consideration to the dimension of the part. As you can see, it's different, it's -6. And the technology that we're gonna use, same hatch, save and calculate. While we are saving it, and we can see the toolpath that we have created. And if you see, if I simulate it here, before operation, after the operation, as you can see, we have gotten as accurate as we can to get that shape going. Now we can also have the profiling cut. I'm gonna do that. I'm gonna add an extra operation here where we're gonna be touching the surface. We're going to be using the tool that was used on the outside surface, which is the first one, 10 μ. Levels was the same process as before. Technology, we're going to use this time contour, so we can go around and have that profiling cut. And as you can see, we have created that. Okay, so those are kind of the steps that you can be taking in order to be generating that footpath for your operation 2, your machine 2, in order to have a better what we would say a better life cycle. These sort of steps, these sort of steps that the machine will be going on, 5 μ, then 10 μ, 6 μ, then 4 μ, in order to have that rough finish or finishing cut, I mean, we'll be having a CAM cycle. And that'll be the end of this presentation for generating the toolpath using the CAM package. Thank you.